we've developed something that most people think is science fiction. Should I look at you or the camera?
Yeah, you're gonna look at me. We're just gonna have a conversation.
Okay, that's easy. LanzaTech started in New Zealand from an idea around sustainable resources. At the time, people were very focused on the use of plants, so trees and other crops for the production of sustainable materials and fuels. But our view was that in order for sustainability to really get to the point where we're able to replace products made from fossil resources, we needed to be able to access a far larger amount of resources, or a far larger pool of sustainable resources for the production of fuels and chemicals. At the founding of LanzaTech, there were two of us, and we developed the technology based on our understanding of the ability of certain kinds of bacteria to consume gases, particularly carbon dioxide, the classic greenhouse gas, carbon monoxide that turns into carbon dioxide in the atmosphere, and hydrogen. And so there are microbes that pre-existed most forms of life on Earth that can use these gases to produce valuable molecules. And so we wanted to leverage this ability, this natural process, to allow the production of sustainable materials. Through the technology that we developed, we were able, in the first instance, to make ethanol, high volumes of ethanol from resources like steel mill waste gases or gases produced from municipal solid waste. That ethanol that we can make from these different waste resources can itself be turned into aviation fuel. Ethanol is today produced by corn ethanol industry, or from sugar in Brazil. And so by using a technology or developing a technology that can turn ethanol into jet fuel, we're not only able to leverage the ethanol that LanzaTech makes, but also that ethanol that's available globally through the existing corn or sugar ethanol industry. This is where we investigate gas fermentation. This is where we optimize our process for deployment in the field at scale. In each one of these is a small reactor in which we're feeding gas, and there's microbes in there that eat the gas and turn that gas into ethanol. And in each case, we're trying to show that we can reduce the cost or improve the profitability of turning gas into sustainable products like ethanol. So really, this is like a microbrewery, yeah? So we're here showing that we can, in a small way, convert our sustainable gases into products continuously. And those products, of course, can be used for making jet fuel, making replacements for gasoline, or making materials that we use in everyday life. I think the real advantage of our technology is that not only does it offer a path to very high volume production of sustainable goods, it also does this using locally available resources that you find in every country in the world. So the fact that we could exist with a biological process at an industrial facility and continuously make fuel was the first time it all came together. The marriage of biology with an industrial process in the field using a new technology. And no one had ever done this before. No one had ever shown that you could turn an industrial emission into a sustainable product using biology.